Okay, this is a lesson for April 6th. Okay, so cellular respiration, aerobic, meaning needs oxygen. The mitochondria inputs pyruvate here, oxygen, we'll see where, and ADP and phosphate come in. Output CO2, water, and ATP. All right, so structure of the mitochondria, outer membrane, inner membrane, matrix, and intermembrane space. All the interesting stuff's done on the inner membrane. For example, this is the enzyme ATP synthase, and this is a structure called an electron transport chain. There'll be many of these, both of these, on the inner membrane at different points. All right, orientation. Pyruvate comes in, 3-carbon molecule. It's in the matrix of the mitochondria, gets switched to acetyl-CoA, which is a 2-carbon molecule, and CO2 is released. The acetyl-CoA enters the Krebs cycle, as you saw in the other note, and the Krebs cycle churns away and produces more CO2s. The result of all the CO2 production is that NADAs come in and gobble up hot electrons to make NADH. That's where the energy of the food is, in those hot electrons. The NAD is acting like an electron dump truck. It's grabbing the electrons, bringing them to the first part of what we call the electron transport chain, or ETC. They dump off the electrons in the first of these intermembrane proteins. These are transmembrane proteins. And they're also known as cytochromes. Cytochrome, CYTOCHROMES. The first one's called a dehydrogenase. It's an NADH dehydrogenase. It pulls the electrons off the NAD. When the electrons leave the NAD plus is ready to go back and pick up more. And don't forget there's also a hydrogen ion, and it just floats around. It's important. Here. Now, each of these proteins has an affinity for electrons. This second one pulls these ones along, and they sort of do a hopping along the chain. As they do, their energy is removed to run proton pumps. So there are 3 points where protons, H plus ions, are pushed across the membrane. So say here, here, here. So in the end, 3 hydrogen ions get pumped into the intermembrane space. By the time the electrons have done all this, they are very low in energy. They're still electrons, but they have low energy. They have to be removed, or the next ones can't keep coming along. If anything interferes with the removal of this pair of electrons, the one sitting here cannot jump, and the whole system backs up. The job of removing electrons is given to oxygen, so O2. O2 is an input. O2 comes in, takes the electrons, 1 oxygen plus 2 electrons, which are negative, plus 2 H ions, and what comes out of this is water, which is a waste product. So hot electrons from food jump, 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 jump along the electron transport chain. They move horizontally here, and perpendicular to that, the hydrogen ions are being pumped out into the intermembrane space. Oxygen comes in, grabs the electrons, leaves with water as a waste. Now, the energy that was once in the electrons has been stored in a potential. The hydrogen ions are trapped. And if you remember the phospholipid bilayers, both this layer and this layer, both these membranes have 0 permeability to ions. No ion gets through. They're all trapped in there, and so you have an enormous hydrogen ion potential. There's only one escape for hydrogen ions, and that is through what's called ATP synthase. It does not have to be located beside the electron transport chain. It's located all along the inner membrane. ATP synthase is a facilitated diffusion protein. It facilitates the movement of hydrogen ions through it. The port here is just the size for an H plus ion, and in it will go like this. However, it's a gated channel. It does not open until there are two things locked into the pockets here. And those two things are ATP and a phosphate. Until ATP and phosphate are locked in here, no hydrogen ion comes through. Once they're locked in, a hydrogen ion, and only one of them, is allowed to pummel through here and enter the matrix again. The energy of its movement from a high to low concentration through facilitated diffusion, that energy is used to bind together these two elements to make ATP. ATP is a product of the mitochondria, and of course ADP and phosphate are inputs. So, recapping that, energy comes from food in the form of pyruvate and all the other intermediate molecules. They are oxidized, and when they are oxidized, their electrons are picked up by the NAD+. NAD+ comes along here, makes NADH. NADH dumps off the electrons, and out are the pumped hydrogen ions when those energy is extracted. By the end of the chain, the electrons have low energy. Once the NADH dumps off the electrons, what's left over, NAD+ comes back to pick up more, and they just do this cycle over and over again. And by the way, the other truck, FADH2, also comes from the Krebs cycle. It's very similar, but the only difference is it's not quite as energetic, so its electrons get dumped in the middle of the chain, and therefore are only good for 2 protons. Once they dump the electrons, back goes FAD to pick up more. And that is the whole thing. For every 1 NADH, 3 H plus ions come back through, and therefore 3 ATPs are made. 3, 1 for each of them. I hope that was understandable. Ask me questions online or in person when we're doing a tutorial. Thanks.